In this lesson, we're talking about something that I believe doesn't get covered enough in AI courses, and that's the mistakes, because AI will get things wrong. Not constantly, not even often, but it happens in predictable ways. And once you know what those ways are, you'll spot them instantly and be able to fix them in minutes rather than spending hours wondering why your script isn't working. This isn't the reason to distrust AI. It's a reason to understand it. It's the same as any human. You could ask them a question and they could get a slight bit of it miscalculated or a slight bit of it wrong, but by the end of this lesson, you'll have a clear picture of every common mistake that AI can make, how to recognize each one, and exactly what to do about it. Let's go. Now, before we look at the specific mistakes, I want to explain why they happen, because once you understand the reason, the mistakes become much more predictable. Here's the key thing to understand about how AI works. It generates code by predicting what should come next based on patterns from its training data. It does not run the code, it does not test it, it has never seen your environment, and critically, it is extremely confident even when it's wrong. It doesn't just say, I'm not sure about this one, it will give you an answer no matter what, and more often than not, it looks like the correct answer. Now, the four root causes behind most mistakes, the first one is that training data for these AI has a cutoff. AI was typically trained on code up to a certain date, so newer commandlets, updated syntax, or depreciated commands may simply not be in its knowledge. Secondly, it has no live environment access. It cannot see your system, so it doesn't know which modules you have installed or even what version of PowerShell or Linux you're running. Thirdly, it is confident by design. There is no uncertainty flag built into this AI. Errors arrive looking exactly like the correct code. And fourth, it's generalized, not specialized. It writes for the most common scenario. Your specific setup in your edge cases, that's where it can most often go wrong. So knowing these four things, and you already know where to look. Let's get into the actual mistakes. The first one it can happen is hallucinated commandlets. This is where AI completely invents a command that doesn't exist. It looks legitimate, it follows PowerShell naming conventions, and it has plausible parameters, but when you run it, you get an error saying it's not recognized. A classic example could be it tries to run something like get AD user last logon report. It sounds real, but it's not. The real way to get that information is get AD user. So how do you spot it? Well, most often than not, you're going to run the script and PowerShell is going to tell you immediately that it's not recognized. That error is your signal. But how do you fix it? Well, you copy the error exactly as it appears, paste it back into the AI, and ask it to correct itself. You typically aren't going to need to diagnose it yourself, you can let AI find its own mistake. It's pretty good at doing that. The second mistake is syntax errors. These are small structural problems, so maybe a missing bracket, a misplaced quote, or a broken pipe character. The script won't run at all, and you're going to get a parse error telling you which line the problem is on. You can see in an example I've put here that the if statement is missing its closing brackets, one character, which is pretty easy to miss when you're reading through, but any code editor is going to underline it in red before you even try to run it. The fix for both of these is the same. You paste the error into the script of the AI and ask it to fix it, and you'll have a corrected script typically back in seconds. Mistake number 3 is a dangerous one, and that's logic errors. And I want to be clear about why this is the most dangerous type. Typically, the script will actually run with no red text and no errors. It's just going to be doing the wrong thing. The example on this slide shows that a script that's supposed to delete files older than 30 days, but the operator is wrong. It's using greater than instead of less than, so it's actually deleting files newer than 30 days. Everything that should have been kept gets deleted, and everything that should have been deleted ends up staying. The script ran, but it caused damage. So how do you spot logic errors? Well, you dry run first. Always use the what if in PowerShell so you can see what the script would have done without actually doing it. If the output looks wrong, it is wrong. Then you describe the symptom to the AI and it will find the logic error. That's again why we always make sure we're running this in dev or test environments first, never in a production environment, because this type of damage could be absolutely critical to anyone out there. Mistake number 4 is missing error handling. AI often writes scripts that work beautifully when everything goes to plan, but can crash silently or produce confusing outputs the moment something unexpected happens. A file doesn't exist, an account that's locked, or a network timeout. You just don't know that it's failed. The fix is one prompt. You're going to tell the AI to add the try-catch error handling to the script and log any errors to a file with a timestamp. It will wrap the relevant sections and add proper locking in one go. That's why it's so important to actually ask our scripts to have error handling built into them. Mistake number 5 is environment assumptions. AI writes for a standard generic environment. It assumes the Active Directory module is already installed, it assumes you're already on a specific version of Windows Server, and it assumes service names match the defaults. None of those things may be true in your specific setup. You can see 4 common examples on this slide, each one with the wrong assumption on the left and the fix on the right. Assume, for example, that the AD module is installed. Well, the fix is to add import module, Active Directory at the top. Uses a Windows path on a Linux machine. Well, you got to tell your AI which OS you're using when you prompt. It references a service name that's different in your version. Well, verify it first with get service. Or maybe it assumes execution policy to allow scripts, which means you have to set it to remote signed before you start. The pattern here is pretty simple. Be specific in your prompts, tell AI what OS you're running, what version, what modules you have. The more environmental context that you give, the fewer assumptions it's going to need to make. And mistake number 6 is hard-coded values. AI loves to bake specific values directly into the script. Things like a username, a server name, a file path, a threshold, which typically works fine the first time, but the moment anything changes, you're back into the script editing it manually. That's not really automation, that's a script that only works once. The fix is one prompt. Replace all hard-coded values with parameters at the top of the script. AI will then restructure the script with a param block so every variable value can be passed in at a runtime. The same script then works for any user, any path on any server. Just pass in exactly what you need. Finally, mistake number 7. Depreciated or outdated methods. AI's knowledge does have a cutoff date. Anything that changed after that date, so things like new commandlets got released, updated APIs, or replaced functions, AI may not know about it. So it might write something that technically works, but uses a method that the vendor has moved away from. You can see the example here with the TLS security protocol. The old way still works, but there's a cleaner, more modern approach that's now preferred. So how do you spot this? If you see a commandlet or method that you don't recognize, be sure to search it in the official vendor documentation. If it shows as depreciated or has a newer recommended replacement, tell AI what version you're running and ask for the modern equivalent. There's also mistake number 8, which is unnecessarily complex code. This one can catch people out because the script works, it does the right thing, but it's written in a way that's far more complicated than what it needs to be. Nested functions, abstract variable names, or convoluted logic chains can be hard to read, hard to debug, and hard to adapt when you need to change something. Now, the 3 ways that you can fix it is first ask for a simpler output, or ask it to explain the complexity, or just specify your level up front. Set the expectation and you're going to get a cleaner output to begin with. So bringing all 8 mistakes together into something actionable. This is your AI script review checklist. 8 questions which takes about 2 minutes to run through and covers every common mistake that we've talked about in this lesson. You might even want to screenshot this slide, pin it somewhere visible and run through it every time. Those few minutes of checking will save you hours of recovery work, and that's exactly what this course has been building towards.